Hi everyone, hope you're all doing well, having a great time, and of course, staying safe. So, in this lesson, we will try to talk about interaction of light waves, and this is class 9, chapter 15, section 3. So, let's start. Have you ever seen the cat's eyes in the dark when lights shine on them? It actually glows. The reason behind this is that cats have a special layer of cells in the back of their eyes that reflects light. The reason behind this is that it helps the cat to see better by giving the eye another chance to detect light. Reflection is one of the interactions of electromagnetic wave. Since we can see visible light very easily, it is easier to explain light waves interaction by using a visible light. Okay, so what is reflection? Reflection is bouncing back of beams of light when it hits a surface that does not go through it. Imagine the light hits a surface, the surface does not allow the light to go through it, so the light will bounce back. Look at your image in the mirror. You are seeing light that has been reflected twice, first from you and then from the mirror. But why we cannot see our image on the wall? To understand this, we need to learn about the law of reflection. The best way to understand how light reflects off a surface, you can look at a ball that bounces off the ground. If you try to throw the ball straight down against a smooth surface, it will bounce straight up. If you try to bounce it at an angle, it will bounce away at an angle. This actually tells you how the law of reflection works. First, the law of reflection says that the angle of incidence is equal to the angle of reflection. What is incidence? Incidence is the arrival of beams of light at a surface. Now look at the image and you can see that the beams of light traveling toward the mirror, and this is called the incident beam. Then we have a line that is perpendicular to the mirror surface. It is called the normal. Then we have a reflected beam. The reflected beam is the beam of light reflected off the mirror. And also we have between the incident beam and the normal, we have an angle. This angle is called the angle of incidence. So the angle of incidence is the angle between the incident beam and the normal. We also have another angle, which is the angle between the reflected beam and the normal, and this angle is called the angle of reflection. Remember when I asked you a question, I said why we cannot see our reflection or our image on a wall? We can actually answer this question right now. Whenever you are looking at a mirror, the mirror surface is very smooth. Thus, the light beams reflect off all points of a mirror at the same angle. So all the light on the surface of the mirror are reflected at the same angle. This kind of reflection has a specific name. We call this regular reflection. If you look at the wall, you will realize that the wall does not have a smooth surface. So as you can see in the picture in front of you, the light beams hits the wall surface and reflect at many different angles. They don't have the same angle. And this kind of reflection is called diffuse reflection. Absorption of light. When you try to use a flashlight, the things that is closer to you will appear brighter than the light shining on things far away from you. There is actually two reasons for this to happen. The first one is that the light spread out. Now, absorption and scattering is the second reason for this to happen. So you see the light weaker because the light spreads, the beams of light spread out, and because of absorption and scattering. What is absorption? Absorption in optics is the transfer of light energy to particles of matter. So, it is the transfer of light energy to particles of matter. As you can see in front of you, the transfer of energy carried by light waves to particles of matter is called absorption. When a beam of light shines through, for example, air, particles in air absorb some of the energy from the light. So the beams of light becomes dim. The farther the light travels from the source, more light is absorbed by the particles of the air. So the light becomes more dimmer. What about scattering? What is scattering? Scattering is an interaction of light with matter that causes light to change its energy, direction of motion, or both. Scattering is an interaction of light with matter that causes light to change direction. Keep in your mind that light scatters in all directions when it collides with particles of matter. Do you know why the sky is blue? Well, because of scattering. Scattering makes the sky blue. You know that light is made of many different colors, and each one of these different colors has a different wavelength. Now, you keep in your mind that light with shorter wavelength is scattered more than light with longer wavelength. Now, since blue have a very short wavelength, it's scattered more than any other color. So when you look at the sky, you see a background of blue light. By now you know that when light waves bounce off an object, we call this reflection. We have another term. You guessed it right, refraction. Refraction is the bending of waves as the wave pass between two substances, in which the speed of the waves differ. So, refraction is the bending of wave as it passes at an angle from one substance or material to another. What is the speed of light in vacuum? Light travels at 300,000 kilometers per second in vacuum. And when it travels through different materials, its speeds slow down. For example, speed of light in a glass is about 200,000 kilometers per second. So remember, when a wave enters a new material at an angle, the speed of that wave will change. As a result, the wave moves and bends to take a new direction. What happens if the light wave enters a new substance perpendicular to the surface? It completes undeviated, which means it goes directly ahead from one point to another without turning aside. Though you will have to know, because of the variation in speed, refraction still exists. This is why we see the depth of swimming pool is less than it really is. Now look at the picture of the prism. We have a ray of a white light that enters the prism in certain speed. Then the light passes through the prism where the speed of light is slower. The light bends away from boundary between the material. Then the light leaves the prism. The light passes into a material that the speed of light is faster. Refraction and optical illusion. Whenever you are looking at an object, the light reflecting off the object travel in a straight line from the object to your eye, and then your brain will explain light as traveling in a straight line. Well, what happens when I look at an object that is underwater? What happens is the following. So when you look at the object that is underwater, the light reflecting off the object does not travel in the straight line. So the light does not go in a straight line. Instead, it makes an optical illusion. So as you can see in the picture in front of you, the cat seems to be closer than it really is. To the fish, the eye seems to be very far away than it actually is. What about refraction and color separation? By now you already know that light or white light is composed of all the wavelength of a visible light. And we have said this before, different wavelength of visible light are seen by human as different colors. Let's ask ourselves, what happens when white light is refracted? Well, what happens is the amount of the light depends on its wavelength. Waves with short wavelength bend more than waves with long wavelength. And keep in mind that color separation by refraction is responsible for the formation of rainbow. How rainbow is formed? Rainbow are created when sunlight is refracted by water droplets. Let's look at the prism. So as you can see in front of you, violet light, which has the shortest wavelength, is refracted more than the red light, which has a long wavelength. We reached the end of this lesson. So your homework will be the section review in page 295, and good luck.